Welcome back. Hope you enjoyed your break. So the first session today is around what does mass customization mean to you? Now this is perhaps my most excited presentation and not because the technology particularly excites me, although it does, Robin, actually because this is the one typically where customers who embrace any sorts of automation or customization can really see massive benefits. But benefits in terms of reduced cost, so profit for their business. And the results are huge. So me and Robin are going to take you through this session. Before we get started, I just want to run a quick question for you. So we're just going to pop this into the Zoom chat for you in a second. But the first question is, what does mass customization mean to your business? And the four possible answers are, it means an online customer-facing configurator, it means robots, it means control over your salespeople, or it means internal automation. I'm just going to give you 20 seconds or so just to pop your answer in the Zoom box. Off we go. Right, okay, I think we've got the results coming through, so let's have a look at what you put. Right, well, online customer-facing configurator was the largest answer, but it's a pretty even split there. A lot of you thought it was internal communication. Some of you thought it was robots, which is great, and control of your salespeople was the lowest. However, it's a pretty even split there. Actually, very interesting because I believe it can be all four of these areas, and it depends how far and how in depth you go into the world of configuration. So let's get into the slides. So basically, in the past, in the not too distant past, the idea of any manufacturing business customizing or personalizing their products on an individual customer basis, I mean, this has often been frowned upon. Mainly, if I'm honest, due to cost, the time it takes to deliver, and of course the resource that you have internally. Not really because it wasn't possible, but really because of the internal effect of variation really had on your overhead and your time, and that all comes down to your profit as a business. So most companies over the years that I've worked with have always sort of opted towards the sort of standards approach of product development, where you sort of select a number of product variations that sort of fit most customer scenarios. It's normally that sort of 80-20 ratio. Now, of course, depending on what your product is, you may or may not have satisfied 80% of your customers, but you've always got the specials, if you like, the one-off. Actually, the way that I think about it, the world of mass customization, there's really a number of key benefits to most manufacturing companies, to a lesser or greater extent, really. The first, of course, is the obvious example that a lot of us think about, and a lot of you put in the question box, around the sort of car configurator idea. The idea of customers being able to personalize their products, to see and to experience what that product might be up front on a website or in a showroom, is really sort of key to this area. But this is kind of the area that most people think about when they think about mass customization. But of course, we are seeing demand for sort of more personalized products really popping up everywhere, from trainers to I've seen personalized earphones. The common thread really is sort of consumer-focused products. But why is that the case? The other real example for me is where, as a manufacturing company, you have lots of product variation, but often your salespeople are defaulting always to the specials, the one-off, the bespoke. Everything we do is bespoke. We've got plenty of customer examples where they have tried to standardize their product sets over the years, but more often than not, the salespeople are defaulting to one-off specials, trying to keep that customer happy at all times. Of course, the effect on that is, increased resource on demand on the design office. If you could find a way to sort of almost control salespeople, and I speak as a salesperson myself, with automated designs of some description, this can have a huge effect on the resource requirements of the design team, who potentially are now able to really focus on what really is the one-off special and not the day-to-day mundane. But actually, from most manufacturing companies can see some form of benefit from automation, even if your products are truly bespoke. Yes, perhaps the products are all different, and more often than not, they are fundamentally based on the same underlying design principles. What if, instead of starting from scratch every time, or maybe changing the last design, engineers could actually get to 80 or 90% of the engineering at a click of a button, and then just tweak it on top? How much time would that save? Of course, most of us do think about the car configurator when the term mass customization comes up, but in reality, design automation has a huge effect on profits if it's done right, whether you're designing completely bespoke products or whether you are fully customized. So that's it from me. I'm going to I'll hand you back to Robin. So Robin's going to talk you through a specific example that we've worked on with a customer who actually wanted to do all of these things, keep control of their salespeople, to go straight from sales to manufacturing, all in one hit, and have used automation. And Robin is now going to take you through the rest of their presentation.
Thanks for that, Simon. So yeah, just to bring that example to life that Simon gave on the door sets. So this particular client came to us shortly after the Grenfell tragedy happened. They had a very small design team, and based on what they do, fire doors amongst other types of door sets, they could see that there was the need for a larger capacity for their design team, and people would potentially be wanting to retrofit buildings with more fire doors or better rated fire doors for more of a better point. So they wanted to do that, but they didn't have necessarily the ability to massively upscale their design team and develop those individuals up to the same level as their existing staff. So they approached us and opened a discussion about what they could do using their current team, using our expertise, and using their current tool sets, the Product Design Manufacturing Collection, and namely Autodesk Inventor, to drive more automation and to drive some faster production. And essentially what we put together was a complete end-to-end configurator for the teams over there, which would take typically what was, a number of days to potentially weeks worth of work, and strip that down to a few minutes automatically in a configurator. So what I want to do before we get too in depth in this technical part of this session is literally just to show you a recording of this configurator that we put together for the team, and just explain a little bit about what it does, because it's very interesting about how far you can take these iLogic based rule sets, forms and configurations should you need to. So we've got something that's literally end to end. So it starts in the back end, and it's literally controlling a project. So in this case, we have what we call an inquiry. That inquiry is a project, and therefore has a naming convention, which it sets out. It puts a folder structure in place and allows you to configure it with a number of different properties and parameters regarding that particular project, which are obviously then called off later on. And then that particular project will start with a door set. In this case, we've just inserted one door set, and you can see that quite quickly, although this video is clearly sped up, we can start affecting that particular door set, changing parameters based on information, so what it's used for, changing parameters based on its price, or even changing configuration, such as it's a double door, not a single door, it's a push bar exit, it's a handle exit, it's got a glazing vision panel, it's got a kick plate, and things like that. We're going in and we're configuring this door. or configuring this door, sorry. And those of you with eagle eyes will notice that in the background, when it's doing those updates to the model, it's also flicking up the drawing, because this is also, as well as configuring the full assembly, all of the parts within that assembly, it's also automatically generating a drawing, a bill of materials, a GA, and some PDFs alongside that as well. And as this starts to progress, you can see on the screen now some QR codes that it's generating in the background amongst some other information, is you end up with a project that's full of door sets. Those door sets are different configurations. And those on their own would take, days to model all up individually. It's automating that based on some internal standards. We then press a single button and it's producing a GA and an individual manufacturing drawing for every single door set in the project. They're squirted out to PDF. And on those, you've also got cover sheets, you've got pricing information, you've got quoting information, and you've also got technical manufacturing drawings as well. So you're literally getting an end-to-end output directly from that single point of contact. And literally it's taking weeks worth of work into minutes. So that kind of shows you how far you can get with iLogic. As a configuration tool or an automation tool, it can be used for anything from the automation of a mundane task, something that you don't want to do day in, day out, hour on hour, minute on minute, because it's just too repetitive. But as you can see from this video, with a little bit of thought, a little bit of understanding from our side to see what your issues are, what your struggles, challenges, or aspirations are as a business, you can really start to drive these things forward and produce, quite frankly, some stunning results outside of standard functionality inside of Inventor. Some of you may be looking at that and thinking, well, that's great. Others might be thinking, okay, how do I start doing that? I mean, how is this thing difficult? How do we start going on a journey to look at what we can do with this kind of out-of-the-box functionality in Inventor? And actually, to get started, it's relatively straightforward. Obviously, we have the expertise and the knowledge that we can help and share with you throughout any means that you might require, be that training or some scoping and some discussions. But what I want to do now is just show you how quickly you can actually get started on your own, bit of self-tuition, even following something else online to try and get you started and maybe just give you a taster of where you can get to without too much difficulty. So we're going to take a break from the PowerPoint, which is great because I like to be out of PowerPoint inside of products. So let's jump into Inventor and let's show you two examples. One where we've got something that's kind of pre-made and you can actually see me driving an iLogic model in person. And then we'll strip that right back. We'll start with a brand new model, nothing in it, and we'll literally draw something pretty simple because we're limited on time, but we'll throw in some iLogics from scratch and you'll start to get an idea of how it works, how we understand it, and what we need to do to develop that moving forward. So I've just opened up Inventor. 2021 is what I'm using for the purpose of this demonstration. But actually what I'm showing is not version specific. I'm going to try and focus on generic iLogic and out of the box functionality today. So whether you are current, whether you're on active subscription and you're 3 versions back, you might even have a perpetual version and you'll be running 5 versions back. This is kind of iLogic bare bones. So this has been around in Inventor for a number of years now. I can't remember the exact release that it first came out, but nothing specific to what I'm using here version-wise. And really where I wanted to start this session today was focusing around 2 areas. So number one, you've just seen a great video of kind of, in my opinion, the pinnacle of where you could get to with iLogic, a full end-to-end automated configurator. And I really wanted to strip that back in 2 phases. Number one, strip it back and show you some basic part or assembly-based automation and kind of how that works. And then strip that back again to show you how you get to that point. So inside this assembly, which you're going to see several times throughout of the technical sessions today. So this facade, we kind of tell a story about throughout the course of the day. So you'll get used to seeing this data set. Really nice data set, well put together. and actually a great use of iLogic in the purpose of this session, because naturally this is something that comes in all different shapes and sizes. They might be a meter long, they might be 750, they might be 2 meters, they might have 5 slats, 10 slats. Those slats might be at an angle for solar shading. There's a number of different things in here that you could configure. And done correctly, we can have a product here that's set up that's controlling all of those. And actually, to get to this point, it's not overly difficult to think about what you need to do. A bit time consuming to put the bells and whistles in place. But essentially, we have an assembly. Inside of that assembly, much like any others, we've got a load of parameters. And in a typical assembly, you might not have loads of custom parameters. You may just have parameters that are driving a joint or a constraint. In this particular instance, if I scroll down, you can see that we have a wealth of user-based parameters. I'm not going to go into the nth degree of those today, but they're controlling different things inside of this model. For example, the bracket offset on both the left and the right-hand side, the gap between each of the individual slats, the number of slats, the angle of those slats, or the angle of the awning, should I say. And the reason that those parameters exist is because they are referenced. So inside of iLogic, which is essentially some simple VB-based code, it points towards a parameter or a series of parameters, and it changes them. Those in turn are linked to a constraint or a part or an assembly or a drawing or an iProperty. And by updating those, it updates the model or the drawing or the BOM or whatever else it's linked to. So for the purpose of this, what you can see is this nice model, looks great. And if I go to my iLogic tab in my browser, if that's missing because you've not used iLogic before, you can head over to the View tab. You've got this user interface drop down. You've got iLogic just here. Or in 2020 and newer, you can press the little plus to show different tabs automatically. So if you don't have iLogic and you want to get started, you can just show it. Now, for the purpose of this, I'm not jumping into all of these different tabs and going through a full, click by click, how to do this and how to do that. But we have rules and we have forms. For the purpose of this, I'm just going to open up a form and explain that within that form, we have a number of different things that are controlling rules. So a rule tells Inventor to go and do something. A form just controls that. So for the purpose of this, I have a form on the left-hand side here, and I've just got a basic drawing that's going to explain what it is that I'm changing. So for the dimensions, I might say, well, I don't want 10 slats. I want to have 8 slats. So I can come in and either type in or use this slider to control how many slats I have. It might be that I want to apply that and see that change straight away, in which case you'll see the model go ahead and update. And not only has it changed the number of slats to 8, if you watch again, I'm going to drop it down to 6. It's changed the number of slats, but then it's regenerated the model so that any constraints, any gaps, everything's updated. And this slat gap on the right has gone from being something considerably less than 96 millimeters to 96. So everything's becoming calculated and it's being controlled by iLogic as we go through. It might be that I want to change the thickness. So we've got some standard sizes here, 20 through to 60 millimeters. And by changing those, it's going to change the thickness of those slats. And again, everything relating to those, such as the bracket positions, where they sit within the model, will all update, which again is fantastic. I can come in and start changing the angle. So maybe let's say that we want to have 10 degrees. I want to go down to 6 slats. And I want to have a 45 millimeter thickness on those slats. If we apply that, it will go ahead and do all of those changes. And this is where you start to say, okay, this actually looks pretty cool. I'm no longer just changing one thing at a time. I can actually come in and start controlling a number of different things about this part, this assembly, this configuration, and I can change them on the fly. And all of this is just visualizing for now. I mean, it's just an example to show you how this works. But it's a really nice example to explain what it's doing and why it's doing it and how it's doing it. As well as working, in this case, with the overall dimensions or the brackets themselves, the slats themselves, I might want to go and do something specifically on the brackets, for example. So I might want to turn off an equal offset and just change one of the offsets individually. Go ahead and hit apply, wait for it to upload, and it will go ahead and change those offsets. You want them to be equal again, tell them to be equal, and it will once again go and update the model. Maybe I want to have more grooves in the panel there at the back. I can turn that up and down. Everything starts working automatically. We can even start doing a little bit more on here. So I'm just going to reset this back to defaults with a nice handy reset button, which will just put this back to its maybe its standard configuration. And then I'm going to show you that we can also do things like controlling level of detail. Now this isn't necessarily going to drive an Inventor LOD. This is actually turning things on or off dependent on what you set inside of iLogic. So it's actually giving you some more functionality to perhaps control how this might be shared with a BIM authorer later down the line, which you'll see a little bit later on this afternoon, in how we control the different look and feel of those products before they're exported out into Revit. So what we have there is something that works really well. And naturally in the background, if I just go and open up the drawing for this particular model here, and let's go ahead and open up the standard GA, just to really bring this all together. We have a drawing. Naturally that drawing, if deferred updates weren't turned on, in this case I've deferred my updates. If my model updates, my drawings update. And this kind of links back a little bit to what we showed you earlier with the client configurator that we worked on. If I just go and open up my iLogic just here, go into my form, I'm just going to make a change. So maybe we'll go down to 5 slats and we'll apply that. And maybe we'll also just change the angle to 10 degrees perhaps. Need to keep remembering that I didn't make that a type in, I made it a slider. So let's apply that. And if I go and jump into my drawing, turn off defer updates and make sure I'll just skip the references for the purpose of the live demo. You get the picture. Because I've deferred updates on the drawing, it's lost some of the references there. But as you can see, based on the configuration, 5 slats and the angle, the model therefore went and updated, which is kind of what you'd want it to do. If I go and set more slats, jump back into the drawing, give it a couple of seconds, it updates. So that served me right for going and showing something that I didn't necessarily plan to show as part of this this demo, but hey, the joy of live demos. So that aside, we have a configurator. That configurator drives, in this case, an assembly through a series of rules. Now, this is all very well and good, but actually, how do we get to this particular point? Now, what we have is a series of rules. Now, I'm not going to go through all of these rules in this model because they're already developed. If I go and edit one of those rules and show you that we've got a load of different lines of physical code in there, it's not necessarily going to mean anything to you if you're new to this stuff. So what I do want to do is now strip this back again and literally show you how we start getting to this point of using Inventor with iLogic. And I'm just going to do this on the fly, just so there's no cotton pulled over people's eyes, no wool pulled over people's eyes, sorry. And you really understand how that works and why it works. So I'm just going to change my project here from the Autodesk sample model. We're just going to jump into a default project. And then from there, we're going to start a new file and we'll just use a simple piece of sheet metal. And with that piece of sheet metal, maybe we'll just do a standard L bracket, put some holes in and show you what we can do to start driving it. Now, I'm at part level, so I'm keeping it nice and simple for the purpose of this demonstration. But as you've just seen, we can do assemblies. And as you saw earlier, we can do all the way to automated drawings as well. So let's start off, as you would in any other part, by creating a standard sketch. On that sketch, I'm just going to draw on my plane here. I'm just going to start drawing a standard face in sheet metal. Now, the main difference here that I'm going to do is I'm going to start placing dimensions and parameters from those dimensions quite early on. If I was normally coming in and drawing, maybe I would just place in some dimensions and just not too worry too much about them being D1 and D2. But in this case, I actually want to name them because that makes my life so much easier moving forward. So I'm going to start by saying, well, this is going to be my width. And I'm going to say width equals, let's say, 350. And then we're going to come in here and we'll say that one is the depth. And we'll say that that equals 150. So all I'm doing is I'm giving it a name and then typing equals. By doing that, you're telling Inventor that I want to name that parameter, which for anyone that doesn't know, if I went into my parameters dialog box and had a look, it basically creates some model parameters with those names and those values. So rather than having D0 and D1 in Inventor, your default first two dimensions, you've got one called width and you've got one called depth. Now they're a little bit too big for what is going to be, quite a small bracket. So in this case, I'm going to say we've got 150 by, I don't know, about 50. Will be absolutely fine. Maybe a little bit deeper, 75. And from there, I'm going to finish the sketch. I'm not too fussed about my sheet metal defaults for the purpose of this. I'm just using the standard 0.5 mil thick rule. Maybe I'll just make it a little bit thicker just to make it a bit easier on the eye. And literally, I'm just going to create a face on here, and I'm going to press OK. From there, I'm going to flange on this edge upwards 90 degrees, and I'm going to go upwards by a height. But I don't necessarily want to just pick any old height. I want this to be symmetrical or asymmetrical in both directions. So, I'm just going to type in here, well, I want that to be depth. I don't need to give this one a name because it's just driven off this. I might say that I want to control them separately and therefore make that height equal something, but it doesn't need to be that complicated with this particular example. So I'm just going to say that equals the depth. What I do want to do is change the angle. So I'm just going to change that to angle equals and make it 90. So far, really straightforward. We have a simple angle, depth, and length. I'm just going to go back in and change that thickness again. I know I said I'll make it 1 to make it a little bit easier, but I'm going to make it a little bit bigger still just to make it even easier to see on the eye, just so it looks a little bit more like what I'm after. So there we go. We've got our component, and anyone that's used Inventor will know that I can go into my parameters now. Let's just come across, and apologies for the size of that dialog box. It's because of the 4K monitor that I'm plugged into on the other end. My apologies to that. It's not scaling particularly well, but what we'll do is we'll just go and find our width at 150, and I'm just going to up that to 175, and I'm going to change my depth to be 100. I'm going to press done, grab my measure tool, under inspect, and identify that that has made the change. So nothing different there. That's literally standard Inventor 101 and has been for years. Standard parametric modeling. However, I'm going to go into my iLogic. And in there, I'm not going to do rules for now. I'm going to go straight to forms. I'm going to right click and say add a form. That gives me a simple interface with a form which I can start working with. So let's call this L bracket configurator, or just config for short. And on there, I'm just going to drag and drop some of these parameters that I have. So I have a width, drag and drop, a depth, drag and drop, an angle, drag and drop, and maybe we want to even throw the thickness in there as well. Why not? Maybe you want to start organizing these. So, you could put a picture at the top, should you want to. I'm not going to do that for the purpose of this. I'm going to make it very generic, but maybe we want to come in and say that we want to add a label at the top. That label is going to have a piece of text which is please define parameters. And then for each one of those, I could say that I want width to be a type in, maybe depth I want to be a type in, but maybe the angle down in here, rather than a text box and a type in, I want that to be a slider. Slider properties could say it's unlimited. They could say that they are minimum maximum values. So we could say minimum angle I want to have is 22. Maximum value we're going to have is 125, and then maybe we want the increment size to be. I'll be simple. So we go from 20 to 125 with increments of 5. Hit OK. If I open up that configurator that we've just put together, or that simple form, should I say, we can come in here and say, I want the angle to change. And it will dynamically update the model live. No issues at all. If I right-click and edit on that form, I can come back and say, okay, well, great, but I don't want a done button. I want an apply button so I can actively see changes on the fly. So we can come in and define that our predefined buttons are OK, cancel, and apply. Meaning that now if I start up that form, I can say that I want this to be 200 and this to be 125, apply. And by the way, I want my angle to be 90 degrees. Press OK. So nice and easy. So very quickly, you can take standard parametric models and you can convert them into form-based models using iLogic. But that's not where the power comes in. For me, the power is there when you start thinking about intelligence and you start thinking about rules and things that designers are having to think about or work out on a daily basis, or things that people just have in their head from the amount of time that they've been with an organization, working with a product, working with a standard or whatever it might be. And that's where rules can really, really help. So I've got this simple design. What I am going to do is change that slider that I put in for the angle. I wanted to show how easy that was to put in. But as you've noticed several times throughout this demo, I much prefer a text box so that I can be a bit freer with what I type in. So let's go in there, and actually we'll take the thickness off. So we'll just right click and delete the thickness out. And we'll hit OK. So from here, I'm going to do a couple of things. So firstly, I'm going to go back into the model, and I'm going to go into my sheet metal tab. I'm going to add a new sketch on this face. Again, I'm going to try and keep this quite simple for the purpose of today, because some of you might be very new to iLogic. So what I'm going to do is I'm going to create a series of holes. So I'm just going to create 3 holes. Those holes I'm just going to dimension like so. I'm not really fussed what the dimensions are for the purpose of the demo, but I'll make them something that's rounded up. So let's just say we're going to go with, let's go from there to there, put that there, accept. So you are going to be this one divided by 2, and you are going to be this one divided by 2. They're never going to change, so I'm just going to leave them as they are. But I've got 3 points, one here, and one here. I'm going to say finish sketch. And then I'm just going to be quite lazy about this. Again, trying to keep it nice and simple. Not necessarily saying this is best practice with Inventor modeling. But I'm going to create my hole tool. Let's just use the newer functionality to get that on the left-hand side, which is great. Kind of reminds me of Inventor release 11, release 10, and older, when you used to have all of the properties on the left rather than, or the tools on the left rather than the ribbon. So yeah, let's create a hole. We're just going to go for a simple hole. And then let's say that for the purpose of this, just, I don't know what, 25 mil, something like that, just so that we've got something that we can see. And that's picked up my centers, and that's got 3 holes. But actually, I only want it to pick up on one of them. I'm going to be super lazy. So I'm going to place this one. I'm going to press OK. I'm going to go into my hole, drag and drop my sketch above to share it. Top tip, if you never knew that, you don't have to right click and share a sketch. Just literally drag and drop it above its feature and it shares it. Love that one. So, sorry, Inner Geek coming out again. I'll continue. So, same thing again. I should have done this with patterns, arguably, but again, I kind of just wanted to show this and give you an understanding about what it's doing. So, let's add one in there and then maybe one in there. So, specifically, I've got 3 individual holes. You could have also done it with a pattern with 3 instances, but I wanted to do 3 separate holes. Now, what we have is hole 1 on the right, hole 2 in the middle, and hole 3 on the left. I'm going to go into my iLogic, go into my rules, right click and add a rule. And let's just call this Virtual Summit. Within there, I'm not going to worry about too much apart from just explaining that it doesn't matter if you know code. So if you know VB, this is based on VB. So anyone that develops in VB.net, VBA and Excel, even standard Visual Basic, they'll feel right at home with this. It's very easy to use. However, if you're new to code, all you need to know is that this is very well supported in the community. So we can help you. There's a wealth of information out there on the forums. It's very easy to get started, but by all means do come and talk to us about some tips. We also have a number of snippets that come out of the box with Inventor and allow you to just do stuff. So what I want to do here is say, if the length is a certain size, it's two holes, sorry. If it goes over a certain size, then it turns on the third hole. So just some basic configuration-based logic in there. So all I'm going to do is say, well, I want an if statement. So I've got a button here that says, well, place an if statement. But I want to replace my expression with an actual expression. And literally, if I just expand these nodes at the top, I can go in and grab stuff that exists in the model and then cheat, double click it, drag and drop it. So I'm going to come into my model parameters and I can see that I have all of my parameters that I created earlier on the right hand side here. Okay, so I've got my model parameters for thickness, width and depth. I'm going to say if double click width is less than, let's say if it's less than 100, then. And then I'm going to scroll down and say hole 1, right click, capture current state. What that does is it gives me a comment. It says whether or not it's active, and it actually even grabs the dimensions of the hole as well. I don't need those for the purpose of this, but it means that I could resize the hole as things get bigger or smaller. So if the width is less than 100, then hole 1 is active. Hole 3 is active, but there's not going to be a middle hole, which was that hole 2, the one in the middle. So if the width is less than 100, there's only a hole on the left and the right. If I save and run that, it doesn't work. The reason it doesn't work is because I've been a little bit lazy. Because I left it on false rather than true. Sorry, left it on true rather than false. So let's just save and run that. Go and grab the... okay, bear with me. Again, the joys of live demos. Let's go into there and grab the width. Have to add the millimeters to the end. Okay. So if it's less than 100 millimeters, save and run. Good. Go on the form, go into the bracket. It's currently at 200 mil. If I go and change that to 99 millimeters and apply it, we get 2 holes rather than 3. If I change it to 100 and apply it, we get 2 holes. If I change it to 101 and apply it, still get 2 holes. Why? Well, I haven't told it the opposite. I haven't told it, if anything else, then put 3 holes on there. So quite simply, we can go back into the rules, edit it with a right click, and say, okay, well, if anything else happens, copy all of these, paste them in, make them all true. Meaning that if the width is more than 100 millimeters, it will turn on that third hole. Now, this actually gives us a little bit of a problem, as you can see here, that you would never be able to manufacture that. So all I'm going to do is go in and tweak that, use a little bit of logic and say, well, actually, that should be anything over than 150 millimeters. Therefore, my form now, if I open it, change that and put it on 160, I get 3 holes. If I change it to 149, I get 2 holes. And that's just a quick example of how quickly you can start working with iLogic. Really simple example that's explaining, okay, you've got some VB code. You've got something that's allowing you to control the parameters inside a component. I've shown you 2 examples, or 3 if you include the video, of full end-to-end workflow just having a parametric model and now having a simple, how do we get started, just to give you a taster. From this point on, it's just a case of, okay, is this something that we can help you with? Do you want some advice on how to get started? That could be some fundamentals training. That could be a discussion about, well, we quite like the look of this fully automated procedure, actually. Can we have a talk about it? The world's your oyster at the end of the day. You already have the software with Inventor that allows you to do this kind of stuff. It's just a case of, is it useful? Have you got use for this in your workflow? And if so, is there anything that we can help you with? So I'm going to jump out of Inventor now and just go back into the PowerPoint and start wrapping things up. So back into PowerPoint, I'm afraid, but I've literally got just a couple more things to say before we go into a short break. So really, I just wanted to push what hopefully you've seen as a huge potential or opportunity more than anything else to maybe get a little bit more out of your investments. Start seeing some bigger ROI on those investments to your subscriptions, because again, this is all out of the box stuff. It's not an add-on, it's not a bolt-on. It's just, is there anything that we can do to make things easier? Whether that is as simple as dragging and dropping some parameters onto a form, like I did first of all in that very simple demo, or if it's looking at going, the whole hog and looking at a full end-to-end configurator. I think these things are more accessible now than they have ever been before. There's so many different ways that we can tap into those different workflows and use them either on a small, let's do a mundane task quicker. Let's automate that mundane task. Let's take every face in this sheet metal part and just export the DXFs automatically so we can import them into another piece of software. Let's go and just create PDFs automatically whenever we do something. All that kind of stuff. It's accessible and it's not too difficult. We can support you in it. We can help you with it. So yeah, let's see what we can get to. But really interesting session that for me. So thank you for joining us for the session. Now, a couple of bits. So we're going to have a short break now. So it's the first session, technical session that we've been through this morning. So this pattern kind of continues. You've had your keynote with a short break. We then now had our first technical session, if you like, and we're going to do the same thing. So we have basically a 15-minute gap now for you to go and have a quick screen break, go and grab yourself coffee, check your emails, do whatever it is you need to do. Throughout that break, we'll be playing some videos, should you want to watch them, with a bit of music, so it's not too dull just watching a blank screen. But more importantly, myself, Simon, and all of my team are here still to take your questions. So at the bottom of your Zoom panel, or on the right, depending on what system you're using Zoom on, there's a little Q&A section. If you go into there, you can ask us a question. We're not doing them verbally live, if you like, today, because we're just so pushed for time with the good content that we have. But we are there live all day answering the questions online. So please jump on if you have a question for myself, for Simon, for any of the other guys that are running sessions today, or indeed any other question that you might have that you want answering. But yeah, thank you very much for your attention in this session. Thanks for taking the time. Enjoy your break, and we'll see you on the other side for a session from myself and Chris on internal collaboration using some Autodesk Vault.